So let's start the session. In the previous session, we have learned about VLAN, VTP, STP, RSTP, Ether channel. So all these topics we have learned, correct? These topics are known as the switching related topics. They come in the category of switching. Now, from today, we will start the routing related topics, routing related discussion. So in routing, there are two types of routing. One is static routing, other is dynamic routing. Dynamic routing like OSPF, EIGRP, BGP, they all come in the dynamic routing protocols. So first we will understand the need of routing. We will create a lab and we will understand why do we require routing. Then we will understand how the routing can be achieved static, meaning manual. And this static routing becomes very challenging for big office, big companies. It is very complex. So big companies, they don't go for static routing, they go for dynamic routing. Because dynamic routing is easy. And mostly in the companies, dynamic routing is used. Then why should I learn static routing? You have to, as a network engineer, you have to. You should know what is static routing. And then it is easy for you to understand dynamic routing. It will be easy for you to understand OSPF, EIGRP, BGP, these routing protocols. It will be easy for you. So in this session, we will be focusing on static routing. So what our focus will be in today's session, we will first create a lab that will put a question mark that why do we need routing, and then how static routing achieves that. Then dynamic routing will also achieve the same thing, that is the routing, but in a different way. Okay, so it will take time to learn. So that's why we have divided this routing in multiple lectures. So first we will create a lab that is need for routing, that will put up a question that is need for routing, that why do we need routing, that in scenario base we will put, and then we will achieve routing with the help of static routing. Okay, now the thing is, if you remember in the previous lectures, we have learned about wide area network WAN. And we have learned that if there is a company that has an office in Mumbai, in Mumbai they have a LAN, Mumbai router, switch, computers. In Mumbai they have a LAN. And they have a LAN in Pune. So they have a LAN in Mumbai and they have a LAN in Pune. And they want to connect their LAN. So can they connect directly? Can they take a cable and connect the switch? No, they cannot. So they are not Superman. They cannot do this. So they require the help of an ISP. And ISP people will tell to take a device that is known as router, which connects to different network. So as we have discussed in the previous lecture that routers are mostly replaced by L3 switches. The answer is yes. So can I do routing on L3 switches? Yes. So in today's session, I will teach you, my dear friends, routing on router. Then in upcoming session, I will replace router with L3 switch. Step by step, we will go. All things in one plate, I will not put. It will be heavy for you. Because in L3 switches, VLANs come. So VLAN will also come and routing will also come. So you might get here and there. So first we will focus on routing. Then in the upcoming lab, we will add VLAN plus routing on L3 switches. Okay, that lab will also come. So here this company says that we have taken up a link from Tata, from the Tata ISP. Link is been taken. So simply we denote this with a single line like this, that this is the ISP link taken from the Tata ISP. Now the point is that what all configuration we have to do. This only physical connection is given by the ISP. This is a private connection. Also we can say point-to-point connection. So it's a physical connection given to you by the ISP. That's it. What configuration you have to do, that we are going to learn in this session. What configuration we have to do, that is known as routing. So how many ISPs in general? In general, major ISPs, Tata, Airtel, Jio, Sifi. These are some popular ISPs. Then other ISPs can also be there, but these are popular ISPs, meaning Tata, Airtel, and Jio, meaning Reliance. These are the top ISPs in our country. Now, my dear friend, out of which the best service is given by whom? If the link goes down and you follow up with the ISP and the link comes up quickly or you get proper update, that is known as best service. So way back when I was working in NOC in 2009 to 2010. So when I started my career as a network engineer in 2008, I was not having all this knowledge which I am teaching in CCNA. That I learned after multiple years. This course is designed from real experience. After multiple years working in the company, things which are learned is put in the course. At that time, meaning initial job, I was not having no knowledge of configuration, routing, nothing. Just knock, network operation center. Link goes down, follow with the ISP, get the link up. Mail everyone, link is down, mail everyone, link is up. We are following with the ISP. This ETR is 4 hours. Like that, we used to mail the stakeholders. So out of my experience, it was Tata was the best. Their response, their reply, they used to call to us after service feedback. Other ISPs were not even reaching that point. Now, coming to our discussion. So link will be taken by the ISP. Now, what configuration we have to do at Mumbai side and Pune side in our office, that we will discuss. So we will take a simple example in today's session. Then slowly we will add complexity in upcoming session. Simple example that in Mumbai, we have a subnet 192.168.0.0/24. You have to memorize this because this lab will be used in the next session. So you have to save this lab. If I forget, my dear friends, you have to just ping me up to save the lab. Now, this, if I say that in Mumbai, 192.168.0.0/24 subnet is being used. So if I do subnetting, what I get? What is the network IP? What is the broadcast IP? Network IP is 192.168.0.0. Then if I'm wrong, you have to tell me. And the broadcast IP is 192.168.0.255. So in the company, if someone writes like this 192.168.0.0/24 we are using in Mumbai, it should meaning at least for /24. I don't say that you can memorize all the subnet mask. For that, you can use the subnet calculator, but at least /24 you should know. This is the least. So for others, you can use like 0.0/24 if you put. For other also, for /24 also, if you have some issues, you can go here. Jodi subnet calculator will help you. 0.0 is the network IP, 0.255 is the broadcast IP, 0.1 to 0.254 are the usable IPs. So my dear friend, all the computers in Mumbai, they will get the IP from this subnet. One subnet, no L3 switch, no VLANs, because they come in L3 switches, VLANs come into picture when you have multiple departments, multiple subnet. Okay. So today we will take up a simple example of a company having one subnet in Mumbai and one subnet in Pune. So they don't require an L3 switch, router can do the job. So in Pune, what is the range? In Pune 192.168.1.0/24. This subnet is used in Pune. What is the subnetting for this? Let's see. Subnetting, if I say that 192.168.1.0/24 is been used in Pune, then what is the subnetting? Correct. So 1.0 is the network IP, 1.255 is the broadcast IP, 1.1 to 1.254 are the usable IP. Okay, so this is the subnetting for this network. If I don't know, no problem. Subnet calculator is there. 1.0/24 calculate. 1.0 is the network IP, 1.255 is the broadcast IP, and 1.1 to 1.254 are the usable IP address. Now, my dear friends, all the computer in Mumbai, I need to. Okay, so all the computer in Mumbai, they will get the IP like 192.168.0.1/24 and the default gateway will be 0.254. 192.168.0.2/24 and the default gateway will be 0.254. 192.168.1.1/24 and the default gateway will be 1.254. 192.168.1.2/24 and the default gateway will be 1.254. So all the computers in Mumbai, they will get the IP from this subnet. All the computers in Pune, they will get the IP from this subnet. And this is port number 1. This is port number 1. This is port number 2. This is port number 3 of the switch. This is port gig 0/0 of the router. This is port number 1, port number 2, port number 3 of the switch. And this is port number gig 0/0 of the router. And gig 0/1 on this port, the ISP connection cable is connected at Mumbai side and at Pune side. So here on gig 0/0 on Mumbai, from the Mumbai router, the cable is going to the switch in the LAN. So here what IP we will give? Think. At the router we give IP to the port. Correct, gateway IP. Will it be 0.254? Perfect, you're right. It will be 0.254. So here the IP will be 192.168.0.254. So this will work as a default gateway for this computers. Then this here what IP we will give? Perfect, you are right, my dear friend. Jaspreet. Here the IP is 192.168.1.254/24. So for this computer, it will work as a default gateway. So in Mumbai, we are using 2.1 also came. In Mumbai, let's have this. In Mumbai, we are using 192.168.0.0/24 subnet. In Pune, we are using 192.168.1.0/24 subnet. Now, always you have to remember that the two port of the router cannot be in the same subnet. Meaning, Mumbai router, you cannot go and give the IP 192.168.1.1 or 1.253. No, it will give you error. It doesn't work. Two port of the same router cannot be in the same subnet. Two port will be in different subnet, different network. Router says my two port will be in different network. My job is router. I'm a router. My job is to connect two different network. How you can put two of my port in the same network? Who are you? I will not allow you. So Mumbai router says my two port should be in the different network. All the port, two port, three port, four port, whatever port the router is having, all the port should be in different network. Router job is to route between networks. So here in Mumbai we have a subnet, in Pune we have a subnet. Here between Mumbai and Pune we require a subnet. We require a subnet. A network, a subnet we require. And we want only usable two IPs here, because rest all IPs will be wasted. They can't be used. I require one IP here, one IP here, and both will be in same network. Both will be in same network. Mumbai and Pune WAN connection will be in the same network. Mumbai router two port cannot be in the same network, but Mumbai Pune connection will be in the same network. So the point is, we require a subnet. If we use /24 subnet mask, can I use? Yes, but you will get 256 IP. Two IPs are gone, one for network, one for broadcast, 254 usable IP. Out of that, one IP you will use here, one IP you will use here. Rest 252 IP you cannot use anywhere, because once you use a subnet, you cannot use that subnet again in your office. Example, you have used this subnet in Mumbai. You cannot use this subnet in your Chennai office. How come it is possible that one computer is having this IP 0.1 in Mumbai and one computer is having 0.1 IP in Pune? How it is possible? It will lead to loops. So one subnet which is used in your company, it can't be used again. If you are using, it will lead to disaster. So in company, complete chart is been created that how many subnets we have in Mumbai, how many subnets we have in Pune, what all subnets we have used, then what are the free subnets that can be used, that your company will create proper IP schema. If it is not there, you go and create. In one of the company I went there, some documentation was not there. I created documentations. You have to take initiatives. If you have worked in some previous company, there you have seen something good, you can implement in this company. So my dear friends, and never hesitate from taking good initiatives. We feel sometimes lazy, yeah, who will take the load? See, if you want to become VP, CEO, then you have to take the load. You have to start the habit of taking the load. If you always want to remain at the engineer level, fine. But if you want to go to the team leader level, manager level, senior manager, program manager, then if your mind is prepared to go at that level, CEO level, CTO level, then their load is there. Then from today, from your current job, you can start yourself taking little load. Okay. Now one more thing. Why I want to go to the CEO level, CTO level, senior manager, program manager level? I want to stay at the engineer level. See, for example, if someone is thinking like this, for example, so at engineer level, salary is at engineer level only. Respect is also at that level. Perks, facilities are also of that level. When you go up, everything increases. Okay, now coming back here. So we require a subnet which will give us 2 IP, and we have got the answer. So my dear friend Bhavesh, you have given the correct answer. The subnet mask that we require right now here is not /24. It will lead to wastage of IP. So most popular subnet mask that is used in WAN is /30. /30 will be used. Now how it will be used? Let's see. We will give you subnetting again, that /30 subnetting again in front of you, so that it is a revision for you. Here the IP will be, for example, we have to decide a subnet. So let's decide a subnet of 0 we have used here, 1 we have used here, 1 we have used here, 192.168.2.0/30. So 192.168.2.0/30 subnetting if I want to do, and for example, I don't know, I forgot. So I can go to the subnet calculator, 2.0/30 calculate. /30, this is the subnet mask, 255.255.255.252. And 2.0 is the network IP, 2.3 is the broadcast IP, and 2.1 and 2.2 are the usable IP. Let's see. So 192.168.2.0/30. Network part is how many bit? 30 bit. Host part is how many bit? 2 bit. So 2 raised to 2 is how much? Network part step 1, host part step 2. Step 3, sorry, 2 raised to 2 is how much? 2 multiplied 2 times is 4. 4 IPs. 4 IPs. First IP is .0, last IP is .3. And the first IP is 192.168.2.0. First IP, last IP we got 192.168.2.3. 2.1 and 2.2 are the usable IP. This is the network IP. This is the broadcast IP. Same thing it is telling here, subnet calculator. 2.0 is the network IP, 2.3 is the broadcast IP, 2.1 to 2.2 are the usable IP. See, we did the calculation. How much time it took? So my dear friend, going ahead. So 2.1 we will give to Mumbai router. Gig 0/0, sorry, 0/1 port, 0/0 is in the LAN, 0/1 and 0/1, because the ISP link is connected on this port. So we'll give the IP respectively here. So 192.168.2.1/30 and 192.168.2.2/30. The network between Mumbai and Pune is what? 2.0/30. Okay, this network also I will put here. The WAN network between Mumbai Pune is 192.168.2.0/30. So the network IP is what? 2.0. The broadcast IP here is 2.3. It is 2.1, 2.2. So how many total subnets are being used? Total 3 subnets. In this routing, you have to at least keep this structure in mind, that in Mumbai, this is the subnet, in Pune, this is the subnet, and the subnet between Mumbai and Pune is this one, 2.0/30. Now going ahead, we have to go and create this diagram. Now in this session, I will give you the commands ready-made. You have to copy and paste. Commands we will explain you, we will make you understand. Simple commands are there. And then our focus on this session is on routing. So we want more time on routing. And please do not make mistake while doing the practical. Okay, do exactly. We will go slow. And we will do this lab. And then what we will do is we will tell you that from 0.1, try to ping 0.2. You will tell that we are able to ping. We will tell you from 1.1, try to ping 1.2. You will tell we are able to ping. From 2.1, we will tell you try to ping 2.2. You will tell that we are able to ping. Why? Can even anyone answer? Because they are in the dash network. Choice is same or different. Correct. Because 0.1 is in the same network of 0.2, ping will happen. 1.1 is in the same network of 1.2, ping will happen. 2.1 is in the same network of 2.2, ping will happen. But from 0.1, when you try to ping 1.1, for example, this computer wants to ping to a computer in Pune. Mumbai computer wants to ping to a computer in Pune. Or there is some server in Pune. Or there is some server in Mumbai. And Pune computer wants to ping server computer, whatever it is. So Mumbai computer wants to ping to a computer in Pune. Then ping will not happen. Here routing is required. Okay, so let's do this. It's a very interesting lab. It is a very powerful lab for routing. Please open up the packet tracer. Have you opened up the packet tracer? Done. Perfect. Now, do you see the router? Do you see the router? Router. Perfect. Please drag and drop the router. Drag and drop two router. Have you drag and drop two router? One is Mumbai router, other is Pune router. Have you drag and drop? Perfect. Now, do you see your switch? Drag and drop the switch. Have you drag and drop the switch? Now, do you see computer here? When you click on computer, click on computer. Have you click on computer? Drag and drop some four computers. Two here, two there. Have you drag and drop four computers? Perfect. Now, once you have done this, now click on this, and do the connection the way we do. Okay, exactly. Connection is very important. If you do wrong connection, 0/1, you connect on LAN and you give WAN IP there, it will be all complete mess. Okay, because router is 2 port. Any port you can use for LAN or any port you can use for WAN. You have to give the correct IP. Okay, but do it according to me and do the exact port numbers. If you make a mistake, because people, I have seen people do some random connection and they follow the trainer. So I go to gig 0/0 port and they at their side have done some different connection and they're giving some different IP. So issues will happen. So click on this, connect the computer to the switch, Do this step by step. Even though I know how the connection and all that, just leave it. If you want to save your time, my dear friend, and save some disaster, then do exactly what is happening on the screen. So have you connected the computer to the switch? Perfect, that's great. Now connect the Pune computer to the Pune switch. Left side Mumbai office, right side Pune office. Done? Have you done this? Then connect the switch, Mumbai switch to the router. This is the LAN connection, LAN cable going from the Mumbai switch to the Mumbai router. Have you done this connection? Then do the connection of this Pune switch to the Pune router. Have you done this? That's great. Now connect the Mumbai router with the Pune router. Finally, at the last, right? At the last, you have to do the connection. So have you done this? Have you connected the Mumbai Pune router? And your gig 0/1 at the Mumbai side and the Pune side gig 0/1, you must see, right? So can you please go and cross check the numbering? 0/1, 0/0 is here, 0/1, 0/2, 0/3, 0/1, 0/2, 0/3. Is it correct? Is the numbering correct? Exactly the same thing at your side? Okay, perfect. Now, in Mumbai, which subnet we have? In Mumbai LAN, we have 192.168.0.0/24. In Pune LAN, which subnet we have? 192.168.1.0/24. So you have to go to the computer and give the IP 0.1/24 and the default gateway is 0.254. And go to the other computer, you have to give this IP 0.2. All the computers in Mumbai will get the IP from this subnet. Similarly, here in Pune, 1.1 and 1.254 and 1.2 and 1.254. So all the computers in Mumbai will get the IP from the Mumbai subnet. All the computers in Pune, they will get the IP from the Pune subnet. And the subnet between Mumbai and Pune is 2.0/30. That is the WAN subnet Mumbai Pune. So here the IP at gig 0/1 it will be 2/1, sorry, 2.1/30 and 2.2/30. So this is how we will give the IP. Then we will ping from 0.1, we should be able to ping 0.2. From 1.1, we should be able to ping 1.2. And from 2.1, we should be able to ping 2.2 because they are in the same network. So ping should happen. Then problem will happen when we try to ping from 0.1 to 1.1. Then routing will come into picture. Who will help in pinging? How the ping can happen? Then we have to do routing. Now, before going ahead, I got a question that which cable you have connected between routers. So you might see here that this is dash dash one is a cross cable. As we have discussed, cross cable is gone. Okay. Cross cable is outdated. It is gone. Everywhere straight cable is used. In packet tracer, it is still showing that they should update this. Everywhere in the world of networking, right now, straight cable is used. So their team is, we need to pass them a message in their help and support. Okay, so my dear friends, here go to the computer, click on the computer, click on desktop, click on IP. So have you click on computer? Have you click on desktop? Have you click on IP? Now give the IP 192.192.168.0.1. Subnet mask keep /24 and give the default gateway. DNS is nothing, we require DNS, only we have to give this. Have you given the IP? Take your time, give the IP. Done? Perfect. Now the next thing is, go to this computer, go to desktop, give the IP 192.168.0.2 and the default gateway is 0.254. Please give the IP carefully. Done? Perfect. Now go to the Pune computer and click on desktop, click on IP and give the IP 192.168.1.1 and give the default gateway 1.254. Please give the IP carefully. Now go to the another computer, click on desktop and give the IP 192.168.1.2 and the default gateway 1.254. Done, my dear friend. Green means desktop is connected to the switch, correct, and the port is up. So switches ports are by default up. Router ports are by default shut. Remember, router ports are by default shut. Even L2 switch, L3 switch, their ports are up. But router ports are by default shut. That's why you see a red. So have you given the IP, my dear friend, 1.2 and default gateway 1.254? Okay, now you have to copy and paste for configuration for the Mumbai router. Configuration we will build up. You will help me in building up the configuration. Mumbai router. Enable config T. No IP domain lookup. Host name Mumbai router. On which port the LAN cable is connected? From the Mumbai switch, on which port the LAN cable is connected? So the correct answer is, my dear friend Bhavesh, you have given the correct answer. On which port the LAN cable is connected? LAN cable, na, this is LAN, this is LAN. LAN cable is connected on gig 0/0. WAN cable is connected on gig 0/1. So I have to give here interface gig 0/0 IP address. What IP address I have to give? Think. Correct. 192.168.0.254 and the subnet mask and no shut. Exit. Port is shut. I have to make the port up. Now interface gig 0/1. Which link is connected? WAN link, Mumbai Pune link from the ISP. It is connected on the gig 0/1 port. So here what IP we have to give? See, any port can be used. Gig 0/0 is not permanent LAN and 0/1 is not permanent WAN. They both are normal ports. They will do the same job. You connect the cable on from the switch to gig 0/0. So you are giving that from the same subnet IP. Now you connect on gig 0/1 the WAN link, the link which is coming from the ISP, the cable coming from the ISP. So here you have to give the IP correct 192.168, the subnet which we have decided. ISP will not give this subnet. This internal office subnetting we have to do. When you take internet link, then ISP will give you public IP. That we will discuss. Internet link will also come. So IP address 192.168.2.1/30. Now, my dear friend Bhavesh, how you are giving proper answer in subnetting in this lecture because it is challenging. So have you done some practice or what are you're already good in subnetting? What is it? Have you revised your practice? Okay. Because normally people practice after the course, 50% people, which I believe, and then some people who have time, because mostly people who join our courses, most of them they're working, so they don't have time. And fresher people are also there because CCNA and MCSE courses are for fresher only. Fresher and experience both, but fresher can do CCNA MCSE because there is no prerequisite. And you are practicing your practice subnetting, that's good. Now, my dear friend, no shut. So here /30 subnet mask is 255.255.255.252. You can memorize it. See, repeat multiple times. It will go in your mind. It will go in your heart. Repeat it few times. Now exit, instead of exit, end and save. This is the configuration of whom? This is the configuration of Mumbai. Are you getting the point? Simple configuration, giving the IP to the port. Okay, because we have to focus on routing, copy and paste this. People make a lot of mistake. They give wrong IP, they give subnet mask also wrong. Then our time get wasted in this only, and we are not able to understand, meaning we are not able to give proper time. Then we have to extend in the routing part. So copy this and paste it in the Mumbai router. CLI, are you on this page? Have you clicked on the Mumbai router, my dear friend? Are you on this page? Click on the Mumbai router. Click on CLI. Would you like to enter the initial configuration dialog? No. Are you on this page? Perfect. Now please copy and paste. The job is done. Is the configuration done? Just copy and paste. Enable config t, no IP domain, host name, interface, gig, IP address, no shut, exit 0/1, and this IP subnet mask, no shut, and write. Done. This is a simple configuration. Main configuration in this session is the routing one that you will type. Done, everyone? Have you done this? Perfect. That's great. Now you have to help me for the Pune configuration. I will give you hint. Pune subnet is this one, 1.0/24. Pune router IP is 1.254. Pune router gig 0/0 is connected to LAN. Okay, and 0/1 is connected to WAN, the link which is coming from the ISP. And the Mumbai Pune network is 2.0/30. 2.1 we have given here. Here on gig 0/1 what we have to give, and gig 0/0 what we have to give. 0/0 is connected to LAN, 0/1 is connected to WAN. Okay, so we have to give your IP from the LAN subnet and on 0/0, and we have to give your IP from the WAN subnet. Okay, so let's see. So here enable config t, host name I will change. Now here what IP I have to give? Enable config t, no IP domain lookup. Fine, this three commands are same. Host name I have changed. Here what IP I have to give? 0/0. Think 0/0, the cable is connected to the switch, which is the Pune LAN. LAN this subnet. So from this subnet, we have to use one IP as the default gateway. Correct? The default gateway IP should be in the same subnet of the computers. Correct. So the IP that we will give here is 1.254. Okay. 0/1, what IP we will give? That is the WAN link. WAN link is connected, ISP link is connected on 0/1. Think. Perfect. So my dear friend Santosh, 2.2. 2.1 you have given now on Mumbai. 2.2. Subnet mask will be /30. Are you getting the point, my dear friends? 0/0 is connected to LAN, so it will get IP from the LAN subnet. 0/1 is connected to WAN, so it will get the IP from the WAN subnet. Copy. Go to the Pune router, click on CLI. Have you click on CLI? Would you like to enter the initial configuration dialog? Say no. Are you on this page? Now copy and paste. Have you copied and pasted, my dear friend? Oh, but I've not given you know how you copy and paste. So please copy and paste. Now we got a question. If we forgot to shut, no shut, then we can use show IP interface brief and we can find out. Perfect. You are right. Admin down is there, meaning the port is shut. Now, can we go? Now you can see all are green, correct? All are green. Okay. Now please go to 0.1. Please go to 0.1 and from there open up the command prompt and try to ping 0.2. Are you able to ping to 0.2? Perfect. Are you able to ping to? Okay, I will repeat. So what I need to repeat, my dear friend Saurav, that this till here have you done? Have you copied and pasted the Pune configuration? Okay, from ping. Okay, so you have to go to 0.1, try to ping 0.2, it will work. From 1.1, try to ping to 1.2, it will work. From 2.1, try to ping to 2.2, it will work. Because they are in same network. Also from 1.1, the default gateway will work. The default gateway IP that we have given, that will work. Okay. So because the default gateway, as we have discussed, if you remember, the default gateway should be in the same network of the computer. So 0/0, we have given this IP in Mumbai, and 0/1 we have given, sorry, 0/0 we have given this IP in Pune. So 0/0 we have given this IP in Pune. So from the computer, if I try to ping this IP, it will work. This IP, the default gateway IP, it will work because they are in the same network. Same network, it will work. So please go to the computer and try to ping 0.2 and try to ping 0.254. Are you able to ping? If you are not able to ping, you have to tell me. Huh? That means something wrong you have done. And we require this lab for the next session. So if I forget, you have to tell that we have to save the lab. Are you able to ping? But are you able to ping 1.1? So this you are not able to ping. This requires routing and this require a discussion. Okay, you can clearly see 100% loss. Replies coming from the router destination host unreachable. Okay, now can you please go? Can you please go to 1.1 and try to ping 1.2? Are you able to ping 1.2? From 1.1, from Pune computer 1.1, are you able to ping 1.2? Are you able to ping the default gateway 1.254? They are in same network, so you should be able to. But are you able to ping the Mumbai computer 0.1? No. You will see destination host unreachable. Reply is coming, but reply is not coming from 0.1. It is coming from the default gateway. Pune computer's default gateway is this 100% loss. This ping will happen only after doing routing. Okay. Now go to the Mumbai. Go to the Mumbai router. Are you on Mumbai router, my dear friends? Are you on Mumbai router? From here, try to ping 192.168.2.2. Are you able to ping? The first packet might be dropped because in the backend, your router sends the R broadcast packet and get the MAC of the 2.2 because they're in same network. Source IP 2.1, destination IP 2.2, source MAC, this router MAC, destination MAC is not known. So router can also create R broadcast packet and then it is sent to the other router, it gives the reply. And by the time the first packet is timeout. Next time you ping, you will be able to see complete response. So the point is that you are able to ping, correct? Exclamation meaning success, dot meaning failure. Why? Because they are in the same network. Now we need to understand that why from 0.1 we are not able to ping to 1.1. For that we will take you to the concept of routing, that how the router works. So remember something like this we have discussed. A router is an L3 device. This means router can read the source IP and destination IP of the packet. It can read source MAC and destination MAC also. But the router says for me the important thing is the destination IP of the packet. So whenever the router receives a packet, it reads the destination IP and refer the routing table. For the router, destination IP, for routing, destination IP is important. So see here, my dear friend, now we have to create a scenario here. From 0.1, when we ping 192.168.1.1, the computer will create a ICMP echo packet. ICMP echo packet. Data is some dummy data. Source IP is 0.1, destination IP is 1.1, source MAC is A, destination MAC is the MAC address of the default gateway. This is A. A. This is the MAC address of this interface like RRR. This is the MAC address of this interface like NNN. And this is the MAC address of this computer like BBB. So router interface has MAC address. Computers have MAC address. So what will be the source IP? Source IP will be 0.1. What will be the destination IP? 1.1. What will be the source MAC? A. What will be the destination MAC? The destination MAC will be, if the source IP and the destination IP, if they are in different network, then destination MAC is of whom? Destination MAC is of the default gateway, which is router. So the computer will check who is the default gateway 0.254. But the computer knows the IP. Does the computer knows the MAC address of 0.254? Your MAC is required of the default gateway. Correct. So what the computer will do to get the MAC of this default gateway? Perfect. It will create an ARP broadcast packet. Hey, who is 0.254? Give me the reply. Packet will go to the switch. Switch will forward to all the port. Everyone will drop. Router will give the reply. That you know. And the computer will learn the MAC address of the router. And whatever the MAC computer learns, it puts in its ARP table. So what MAC will be here? The MAC address will be of the router. Correct? If the computer does not know the MAC address of the router, it will create an ARP broadcast packet. Hey, who is 0.254? Give me the reply. Everyone will drop, router will give the reply, and the computer will learn the MAC address. Computer will then put that MAC address here. Now this packet will go via the switch to the router. Now our focus is on router. Switch we have already understood multiple times how the switch works. Now our focus in this session is only on routing. So now the packet goes to the router. When the router will receive the packet, router will look at the destination IP and refer what? You're right, my dear friend. And the router will look at the destination IP and refer what? Whenever the router receives the packet, it reads the destination IP and refer the routing table. Can you memorize this line? This is important line. If a person does not know this line, forget about routing. So can you memorize this line, my dear friend? Whenever the router receives the packet, it looks at the destination IP and refer the routing table. Try to repeat it multiple times. Things will go in your mind and heart. Then, if the router knows how to reach the destination IP, it will forward the packet. Otherwise, it will drop the packet. Now, today's session is focused on this line. And entries in the routing table can be created in two ways, static and dynamic. Today, you will learn static. So, the point is that what is the routing table? Can I see the routing table? Now I have to draw the routing table, current routing table of the route Mumbai and the Pune router. And then we need to understand why the router is dropping the packet. So can you please go to the Mumbai router? Are you on the Mumbai router, my dear friends? Now how to see the routing table? Before the routing table, you have given proper all this and you want to see the interface status. The command is show IP interface brief. Remember this command we have learned. We have explained you about status, protocol, and also many important things. So you can see here all up, right? 0/0, 0/1, up, correct? Perfect. Now, type the command show IP route. The command is show IP route, sh space IP space route. Show IP route. Have you run this command, my dear friends? Now here, how many entries we see? CL, CL. Total 4 entries we see. This one entry is known as route. So in routing table, you have route. These entries are known as route. So we say in the company, a route is not there for the destination IP. That's why the router is dropping the packet. This kind of language we use in the company. So in the routing table, there are routes. Now how many routes? There are total 4 routes right now. You have to focus on the one which is C. Always ignore the one where L is written. L meaning local, meaning what IP you have given, that it shows you that 2.1 you have given, but it does not put your subnet mask. it puts a local individual subnet mask, that is /32, meaning this IP is been given 2 gig 0/1, 2.1 is given 2 gig 0/1, and /32 meaning single IP. So it wants to just pass the information to you that 2.1 is given to 0/1 and 0.254 is given to 0/0 on this port. So L are of no use for us. They are only for information that what IP is given to the port. For routing, important is right now C for connected. So what I will do is I will create the routing table here. And in a detailed fashion, we will create the routing table so that you have a better understanding. Routing table. Focusing on entries like C meaning connected. So the router says that C meaning connected, that on my gig 0/0 port, this network is there. Which network is there? 192.168.0/24. 192.168.0/0/24. This network is on gig 0/0 port. So this network 0/0/0/0/24 is having how many IPs? 192.168 from 0.0 to 192.168.0.255. Remember the subnetting? 0.0/24. This is the network IP. This is the broadcast IP. So 0.0/24 meaning all these IPs. So what the router says, that all these IPs are reachable via gig 0/0. Router says it is directly connected to me only. See your hand. If you look at your hand, they are connected to you know, left hand, right hand. If someone comes and tell you that this is your left hand, this is your right hand, you will say, what you are telling? I know them. They are my hand. They are connected to me. Similarly, router says connected network, meaning they are my networks. They are connected to me. They are like my hands. So router says that when you give the IP 192.168.0.254/24, you have given na on gig 0/0. What IP you have given? This IP you have given 0.254/24. Router knows subnetting. Router calculated the subnetting. This IP 0.254/24. Router did subnetting and router said, I come to know 0.254/24 meaning what is the network IP? This is the network IP, this is the broadcast IP, and all these IPs are the usable IP. So the router puts the entry in the routing table that when you give me this IP, even you can, for example, you see a scenario like this and you don't know subnetting for that, or you require a subnet calculator, you can just go here and you can just put the router IP 0.254/24. There is no harm in using subnet calculator. You can use it. All subnetting, everything you cannot memorize. By practice, you will become better. So 192.168.0.254/24. The router knows that, okay, this IP 0.254/24 belongs to this subnet, belongs to this network. 0.0/24 is the network IP, 0.255 is the broadcast IP, 0.12, 0.254 are the usable IP. So router says all these IPs are reachable to me. One IP you have given not to me. That means all the other IPs are reachable here only on my gig 0/0. So the router puts the entry in the routing table not for one IP, that I know 0.1, I know 0.2 is reachable via gig 0/0, I know 0.2 is reachable via gig 0/0, I know 0.3 is reachable via gig 0/0. No, routing table will be big. So it will harm the router. If the routing table is very big, it will slow down the router. Because whenever the router receives a packet, it looks at the destination IP, refer the routing table and checking like 200 routes, 500 routes, 1000 routes, it will take lot of time. Then the packet processing will be slow, because so many packets come to the router. For every packet, router saying wait, I have to check, there are 1000 entries in the routing table, 1000 routes are there, then I will check where you are matching, then I will forward. So the people who created networking, they know this, so they have simplified. What they have done, they put the network IP meaning all the IPs belonging to this network. So router says all the IPs belonging to this network 0.123 up to 0.255, from 0.0 to 0.255, all are reachable via gig 0/0. I know about them. No one will tell me about them. I know about them. Similarly, on gig 0/1, what IP we have given? 2.1. What subnet mask we have given? /30. Correct? So this 2.1/30, what is the subnetting? This is the subnetting. This is the network IP. So the router puts in the routing table like this, that 192.168, it will not put 2.1/30. Router says I put the complete network. You have given this IP na, I find the network IP of that, and I put the network, complete network. That complete network is reachable via gig 0/1, meaning all the IPs 2.0, 2.1, 2.2 up to 2.0, 2.1, 2.2 up to 2.3. 4 IPs. 2.0/30 meaning total 4 IPs. All the 4 IPs I know. No one should tell me. If I receive a packet related to this IP, I know where to forward. On gig 0/1, I receive a packet related to 0.1, 0.12345, 0.0 and 0.55 are the reserve IP, but related to this IP, if I receive the packet, I know where to forward. So the router says, Mumbai router says that no one should tell me these are my connected network. This is my left hand, this is my right hand. I know about this network, meaning I know about this IP. See, in the routing table now only network is there. In the routing table, only network is there. 192.168.0.0/24 is directly connected via gig 0/0. I have expanded here for your easy understanding in the bracket that 0.0/24 meaning how many IPs it is able to reach. Are you getting the point? In the routing table, it is mentioned the 2.0/30 is directly connected. So I've expanded here that 2.0/30 meaning all these IPs are reachable. And how the router creates this entry is, you give this IP na 0.254/24, router finds the network IP of that, and router says all the IPs belonging to this network are reachable. I know them. You give this IP 2.1/30, router finds the network IP of that, and router says all the IP belonging to this network, I know them. One IP you give, that means all the IP I know. That is the logic of router. Router says yes, all the IPs, all the IPs belonging to this network, they are reachable by gig 0/0. All the IPs belonging to this network, they are reachable by gig 0/1. Now, using this logic, let's prepare the routing table of Pune, the default routing table. Using this logic, you will help me. So this is the Pune routing table. Think, I will give you a hint. What IP is given on the Pune router on gig 0/0? 1.254/24. This IP belongs to which network? Meaning, if you don't know this, you go to the subnetting calculator. 1.254/24, it belongs to 1.0/24 network. Jody's subnet calculator is very best. So here 1.0/24. So router says, so the answer is given by, you are correct, 192.168 1.0/24 via gig 0/0. And how many IPs are belonging to this network? So I'm putting here 1.0 to 1.255. All these IPs are reachable via gig 0/0. Pune router says, yeah, they are connected to me. I know about them. The next is dear IP is given 2.2/30. So think and answer. 2.2/30. What will be the network IP here? Think. 2.2/30. Think, take your time. We have still not got the correct answer for that. Perfect. So the correct answer is 2.2/30. Use the Jody's calculator. Calculate 2.1/30, 2.2/30. They belong to this network only. So what is the network? 2.0/30. 2.1, 2.2 belongs to the same network, na? That is this network, the subnetting which we have done. 2.0 network IP, 2.1, 2.2 are the usable, 2.3 is the broadcast IP. So they belong to this network. So my dear friend, here 192.168.2.0/30 gig 0/1. 2.0 and 192.168.2.3. Perfect. Not think and tell me. Routing table is in front of you. Not tell me. Imagine you are a router. You are Mumbai router. What is your job? You, whenever you receive the packet, you look at the destination IP, refer the routing table. If you are able to know that if the destination IP is matching, you have a matching route, you will forward accordingly. And if there is nothing you don't know for the destination IP, you will drop the packet. You have a simple understanding. Now tell me that you receive this packet, you are Mumbai router, you receive the packet, you look at the destination IP, the packet wants to go where? To 1.1. Do you know? Is 1.1 matching here in this route? What do you think? So 1.1 is not matching here. 1.1 is not matching here. So what Mumbai router is doing? Mumbai router is dropping the ICMP echo packet. This ICMP echo packet is dropped by the Mumbai router, and the Mumbai router is sending a packet to the computer. What is that packet? Computer, the destination which you want to reach now, that is unreachable. I'm very sorry. Destination is unreachable. See here, if I go to simulation is only for the trainer. If I go here and if I go and ping, see here, source IP 0.1, destination IP 1.1, source MAC, computer MAC, destination MAC, router MAC, default gateway MAC. Packet goes to the default gateway router. Router says, if I click on this packet, what is happening? Blue packet, huh? If I click on this packet, router says I look at the destination IP and refer the CEF table. CEF table meaning routing table. And the routing table does not have any entry for the destination IP. So I ask router, what you do now? If the destination IP, that packet wants to go to 1.1 and there is no entry, there is no matching entry, matching route in the routing table. So what you do? Router says, my funda is very simple. The routing table does not have a route to the destination IP. I drop the packet. I've dropped the ICMP echo packet. See, I've dropped that. And I'm passing the message to the computer. I'm sending a red packet to the computer that destination host unreachable. So that the network engineer understands that there is some problem. Are you getting the point? So the router is sending a message, destination host unreachable. So that's what you see here, destination host unreachable. Replies coming from router. Some people, they are very happy. Hurry, reply is coming. Hurry, reply is not coming from 1.1. Reply is coming from the router. Read properly. I have seen in companies, people in front of them, they have the error message. They don't read. You might see a lot of people like this in the production environment, in the company environment, and you might think, yeah, how they are getting paid. Seriously, there are so much different type of people that error message is there in front of them. They don't want to read the error message. They don't want to do some Google on the error message, nothing. Okay. Anyways, in today's world, the world in which we are, it is a very danger word. Layoffs are going on. Things are like going here and there. This is the time of person who is having multiple skill, not just one. That one skill time is gone. Multiple skills is required to survive and get a good package in this world. Anyways, coming back here. So have you understood till here? So what we have to do? Router says, I don't know about 1.1. I am dropping the ICMP echo packet. I am sending a message to the computer. Destination host unreachable. Your network engineer will understand. So I went, for example, I'm the network engineer. I went to the Mumbai router and I said, Mumbai router, can you please go to the Mumbai router? Type the command show IP route. Can you please go to the Mumbai router and type the command show IP route? And now we have to tell the Mumbai router, yeah, Mumbai router, what is the problem? Why you're dropping the packet? Mumbai router says, I don't know about 1.1. I don't know about this IP. That's why I'm dropping the packet. So now we have to tell the Mumbai router with the help of static routing. Now we will configure static routing, but just give me a few minutes and I will be back. Okay, I will pause the record. So my dear friends, thanks for the wait. I'm back. Now we have to tell the Mumbai router that why you're dropping. The Mumbai router says, I don't know about 1.1. So that's why I'm dropping the packet. So we have to tell now. Now there are ways to tell. One is static routing that we will learn today, and then the dynamic routing we will learn in the upcoming sessions. So the point is, my dear friend, in static routing we have to use the command. The command is, in Mumbai we have to go and run this command in Mumbai router, that is IP route. We are telling the router that do routing. Router says for whom? We say here for this destination 1.0/24. Meaning router, if you receive a packet belonging to this network, router says 1.0/24, meaning are you talking about 192.168 1.0 up to 192.168 1.255 and 1.0 and 1.2 1.255 they are reserved, that we have learnt in subnetting. So in short, usable are 1.1 to 1.254. So if I receive the packet like the destination IP is 1.1, 1.2, 1.3, 1.4, they will all match in this network. We say yes. Router, if you receive a packet and the destination IP is 1.1, 1.2, 1.3, they're matching in this network, don't drop them. Router says, then what I have to do? Here the syntax is next hop. Next hop meaning next hop router, or it can be next hop L3 switch, that in a L3 switch lecture we will learn. So here simply next hop router. So here we are telling the Mumbai router that don't drop them. Just send that packet to Pune router. Now, Pune router will take care. That subnet is in Pune. Pune router will take care. You don't drop. See, we as a network engineer in the company, we know that in our company, we have this Mumbai, this network in Mumbai, this network in Pune. So we are telling the Mumbai router that Mumbai router, if you receive the packet, this packet don't drop, forward the packet to the Pune router. What Pune router will do? It will forward the packet to the computer. That we will discuss. But Mumbai router, we are telling here why you are dropping. That network is with Pune now. You forward the packet to the Pune router. You forward the ICMP echo packet to the Pune router. So how the Mumbai router will forward? By default, it cannot forward. Are you getting the point? It requires an entry in the routing table. Entry in the routing table can be created in two ways. One is static, other is dynamic. So now we will learn static. So we have to tell here IP route. Here always remember, we don't give one IP, that one IP, one route. For 1.1 send the packet, 1.2 send the packet, 1.3 send the packet to Pune router. We don't do like this. Routing table will be huge. Routing table is huge. It will slow down the network, meaning the working of the router. Packet forwarding of the router will be slow. So we give for the entire network. Next hop name is not there. Next hop IP is there. Next hop router. Hop meaning router L3 switch. That is the word hop. No subnet. Subnet is there here, no? This is the destination IP. So the syntax is like this, my dear friend. Syntax. There is a syntax of this entry, and I put that in the PDF next to the video. The PDF is here. What is routing? Routing is the process of forwarding the packet from source to destination. Static routing, dynamic routing that we have discussed. Static routing, focus on static routing because this PDF is focused on static routing. It is simple for small networks, but in large network, it is very time consuming and it can have issues because manually you have to configure. And the syntax is IP route destination network. This is the destination network. This is the subnet mask. And this is the next hop IP address. Now next hop meaning router or L3 switch. So this is the IP address of the router that is connecting to the desired network, subnet mask, network IP route. Okay. So my dear friend, this is the syntax. So destination network is 1.0/24 and the next hop IP address of the router is 2.2. So what we are telling to the Mumbai router, if you receive a packet and the destination IP is belonging to this network, do not drop the packet, forward the packet to this router. It can be a next hop, can be a router, or it can be L3 switch, meaning it can be this kind of devices. So why you are dropping the packet? If you receive a packet, like if the destination IP is 1.1, don't drop, forward it to the Pune router. Are you getting the point? Pune network, forward it to Pune router. Simple. So can you please go to the Mumbai router, copy and paste this. Please go to the Mumbai router, type enable, type config t and paste this and end and save. Okay, so if you want, I can create the complete format for you. Done. Perfect. Now please have a look. Now please go to the Mumbai router and type the command show IP route. Have you typed the command show IP route in Mumbai router? Have you typed the command show IP route? Can anyone tell me now one entry is more? I can see one entry more. Perfect. S4 static. This entry. This entry means what? I need some space here. This entry means what? Let's see. S4 static. What is the network? 192.168.1.0/24 network. Send the packet to whom? Send the packet to, this network is not connected to Mumbai router. This network is in Pune. So send the packet to the Pune router. Now what all IPs belong to this network? 1.0, 1.1, 1.2, 1.3 up to 1.255. All the IPs belong to this network. This is the entry which is there in the routing table. 1.0/24. Send the packet to 2.2 for this destination. These are all destination network. It says that this destination is connected to me, this destination is connected to me. For this net destination, if I receive the packet, I will send the packet to Pune router 2.2. Now think and answer. You have told the Mumbai router that for this network, Pune network 1.0/24 network, send the packet to the Pune router. Now think and answer, my dear friend. Now if I ping again from 0.1, if I ping 192.168.1.1, if I ping, my computer will create the packet source IP 0.1, destination IP 1.1, source MAC A, destination MAC is not known. Computer will create the R broadcast packet and get the MAC. Who is 0.4? Give me 0.254, give me the reply. The MAC is learned, the MAC is put in the ICMP echo packet. That all MAC story we have already discussed. This packet is complete. This packet goes to the Mumbai router. Mumbai router looks at the destination IP, refer the routing table. The destination IP is 1.1. Will it match here? No. Will it match here in this route? No. Will it match 1.1, 1.2, 1.3? Example here 1.1. Will it match here in this route? What do you think? Yes. So what the Mumbai router will do? It will forward the packet to the Pune router. Are you getting the point? That is the job of router, forwarding the packet. Now who has received the ICMP echo packet? Who has received the ICMP echo packet? Pune router. Perfect. Now tell me one thing before going ahead and discussing more interesting thing. Are you able to ping? Are you able to ping now? Are you able to ping? Why you are not able to ping? It is very important to understand why you are not able to ping. So my dear friends, let's see. Okay, just give me a moment. Just give me a moment. So my dear friends, I'm back. So the point is, in classroom we have students also in our Mumbai classroom. So someone was ringing the bell. So that's why I went and checked there. Okay. Now ping, here the ping is not happening. Now why it is not happening? That we need to understand. So if I go to simulation, see here. And if I go to 0.1 and I try to ping 1.1, from 0.1, the packet goes to 1.1, source MAC A, destination MAC, the default gateway MAC, source IP 0.1, destination IP 1.1. Packet goes to the Mumbai router. Will the Mumbai router drop the packet? What your logic says? What do you think? Will it drop? No. It will forward the packet to whom? It will forward the packet to the Pune router, which is 2.2. See here, Mumbai router is smart. So Mumbai router will forward the packet to the Pune router. Perfect. After the Pune router receiving the packet, what the Pune router will do, what every router will do, always you have to remember the same thing. Every router will look at the destination IP, refer the routing table. So the destination IP is 1.1, correct? The Pune router refers the routing table is 1.1 matching. Is there any matching route in the Pune router? What do you think? I can see the matching route for 1.1. Perfect. 1.1 is matching here, no? Clearly, we have given all the IPs. 1.1 is coming here or not from 1.0 to 1.255. So it is directly connected, right? It is directly connected. Pune router says, Arey 1.1, you are connected to me only. I know how to deal with you. I will forward you. Pune router forwards that packet to the computer 1.1. See here. Pune router sends the packet to the computer 1.1. So ICMP echo packet has reached from 0.1 to 1.1. Can anyone tell me that after receiving this packet 1.1, what 1.1 will do? It will create a perfect. It will create a ICMP echo reply packet. Correct? After receiving the echo packet, it will create the ICMP echo reply packet. That's correct. Now data is some dummy data. Source IP is 1.1, destination IP is 0.1, source MAC is BBB, and destination MAC is NNN. If the computer does not know its MAC address, it will 1.1 will create our broadcast packet, and the broadcast packet will go to the Pune router. It will give the reply, and the Pune computer will come to know about the MAC address. That the computer knows how to get the default gateway MAC using the broadcast packet funda. That we have already discussed separately in the initial sessions. So now this is the ICMP echo reply packet. Source IP 1.1, destination IP 0.1, source MAC, computer MAC, destination MAC, default gateway MAC, NNN, BBB. Think now this packet will go to the Pune router. Pune router will look at the destination IP and refer what? Pune router looks at the destination IP and refer what? The routing table. The packet wants to go to 0.1, right? Is there any match? Is 0.1 matching in the routing table? The Pune routers, I know about 1.0/24, meaning 1.0 to 1.255, 2.0/30, 2.0 to 2.3. But yeah, I don't know about this 0.1. I don't know. I'm dropping the packet. I don't know about this. I'm dropping the packet. So your reply packet is dropped by the Pune router. It is not going to the computer. Mumbai computer, it is dropped by the Pune router. See here, your reply packet is dropped by whom? See, the packet goes to the Pune router. Pune router looks at the destination IP. Yeah, where you want to go? 0.1. I don't know about 0.1. Yeah, I'm very sorry. The Pune router says I've received the packet like this. Source IP 1.1. Destination IP 0.1. Source MAC, computer MAC, that is BBB. Destination MAC is the router MAC, Pune router MAC, NNN. I've received the packet like this, but I look at the destination IP. The destination IP is 0.1. I refer the routing table, and the routing table does not have a route to the destination IP. I'm dropping the packet. I'm sending the message to the computer, this Pune computer, that destination host is unreachable. So the Pune router sends the message to its Pune computer that destination host is unreachable. How to solve this problem? How to tell the Pune router? I'm coming back to real time. How to tell the Pune router that do not drop the packet? Yaar, Pune router, why you're dropping the packet? Don't drop. How to tell? With the help of static route, meaning routing, static or dynamic routing. This lecture focus is on static routing. So with the help of static routing. Now what static route we have to create for the Pune router? Think. So my dear friend, Jaspreet and Bhavesh, you are the man of the match. And Sorrow and my dear friend, the answer is correct. Okay, so IP route. See what we have to tell the Pune router. Pune router says, I don't know about 0.1. So we will say Pune router, forget about 0.1 IP. You will know about the complete network 0.0 slash 24. All the IPs belonging to this network. How many IPs belong to this network? How many IPs belong to this network? 0.0 slash 24. 2.0, sorry, 0.02, 0.255. All the IPs belong to this network. So this is the destination network. So Pune router, if you receive a packet and that packet destination IP matches this network, don't drop them. Send that packet to the Mumbai router. This is the Mumbai router. Forward that packet to the Mumbai router. Mumbai router will take care. This is known as static routing. You are telling the routers how to forward the packet, otherwise they will drop. You are important. So you are telling the Pune router to reach the Mumbai network, meaning like this simply also we can say to reach the Mumbai network, send the packet to Mumbai router. You're telling the Mumbai router to reach the Pune network, send the packet to Pune router. So this you have to go to the Pune router and type this command. So please go to the Pune router, my dear friend. Are you on the Pune router? Are you on the Pune router? Copy and paste. Done. Okay. Now type the command show IP route. Now type the command show IP route. Show IP route. S for static. S for static. So here, what do you see in the routing table? S for static 192.168.0.0/24. To reach this network, send the packet to whom? To 2.1. What all IPs are matching in this network? Part of this network from 0.0 to 0.255. All these IPs are matching in this network. That's what you see. S for static 0.0/24. For this network, send the packet to the, for Mumbai network, send the packet to the Mumbai router. That's why I told you at the start to memorize the Mumbai and the Pune network. 0.0/24 is in Mumbai, 1.0/24 is in Pune, 2.0/30 is between Mumbai and Pune. So now the Pune router looks at the destination IP, refer the routing table. For this reply packet, what will happen? The Pune router says you want to go to 0.1. Array, you are matching here. I have a matching route for you. You are matching here 0.1. You are matching here. I will forward it to 2.1. So this ICMP echo packet, sorry, echo reply packet will now be forwarded from Pune to Mumbai. Are you getting the point? Because of this route. So forward and reverse, both routing is required. You cannot just create the entry in Mumbai router and leave it. Are you understanding, my dear friend? Packet should go from Mumbai to Pune and from Pune back to Mumbai. This is known as end-to-end routing. You cannot just do routing on Mumbai and leave it. You have to do on the other side also. Now, after the Mumbai router receives this packet, the Mumbai router will look at the destination IP where you want to go, 0.1. Will the Mumbai router drop the packet? What do you think? This packet wants to go to 0.1. The Mumbai router will look at the route. You are matching here. You are connected to me only. 0.1. You are connected to me only. And the Mumbai router will forward the packet to the computer. This is how the reply packet will come. So you know why ping is a very powerful tool. You know why ping is a very powerful tool. ICMP echo packet goes. ICMP reply is coming. So end-to-end routing is okay. Are you understanding? Why ping is very powerful? One of the reason is that it checks the routing also. Packet is going from source to destination and reply is coming from destination back to source. So end-to-end routing is okay. So can you please go to 0.1 and try to ping, my dear friend? Success. Are you able to ping? Perfect. Now please save the lab. In the next session when you come, I will first revise this, then I will take the dynamic routing. Okay. So please go to the router. You have typed WR, correct? On the routers you have typed WR, Mumbai router, Pune router. Have you typed save WR? Now please click on file, click on save and give it a name like static routing and save the lab with the name of static routing. Have you saved the lab? Computer IP automatically it will save. Nothing you have to do. Router you have to do WR. On switches nothing we have done. On the L2 switches. Switches also we will learn in upcoming lecture, meaning big lecture will come. So VLAN we will add, routing we will add, so many things we will add in upcoming lecture, not in one go. So today we focus only on routing. Now we got a question in between, there will be ISP, then his router IP will block our communication. No. We don't have any relation with the ISP's router, meaning our router will forward the packet for 2.1. Sorry, from 2.1 routing will happen to 2.2. In between there are router ISP routers, but for us as if they are not there. They work in such a fashion that as if for us it is not there at all. So they work on their internal protocols they use, internal technology they use. For the user, for us, for the people who have taken up the link, we don't care for their internal routing. So my dear friends, have you done till here? Okay, so that's it for this session. Let's meet in the next session. This lab is required for the next session. Bye everyone.